In our lesson today, we're going to investigate scale drawings. We're first going to discuss what a scale drawing is, and then we're going to look at the ways that we can recognize a scale drawing. So, underneath the box, we're going to define a scale drawing. All right, a scale drawing is a reduced or enlarged two-dimensional drawing of an original two-dimensional drawing, okay? Reduced meaning that it's either going to be smaller, or enlarged meaning that it's going to be larger, okay? A scale drawing is a reduced or enlarged two-dimensional drawing of an original two-dimensional drawing. A scale drawing is always proportional. A scale drawing is always proportional to the original drawing. Okay, so when we're working with scale drawings, we know that we will always be working with a proportional relationship. And so in our first example, we're told that Jake created a simple game on his computer and shared it with his friends to play. They were instantly hooked, and the popularity of his game spread so quickly that Jake wanted to create a distinctive icon so that players could easily identify his game. He drew a simple sketch, and we see right here, that's the original sketch right there. From that original sketch, he was able to create a sticker to promote his game. And here is the sticker. This is what the sticker looked like. But Jake wasn't sure if the stickers were proportional to the original sketch. All right, so if he's not sure if the stickers are proportional to the original sketch, we're not sure if the sticker would represent a scale drawing. And so what we're going to do is figure out if there is a proportional relationship between the size of the sticker and the original sketch. Okay, so what we're going to do in our table, we can see that we've got the top row labeled for the sticker, the bottom row labeled for the original sketch. What we're going to do is take a value from the sticker, and we're going to compare it to the corresponding length on the original sketch. So let's take a look at the sticker, which is this right here. And why don't we take this 1 3/4 section right here. So under sticker, I'm going to put 1 3/4, okay, and that's measured in inches. Now, this length on the sticker corresponds over here to 7/8 inch on the original sketch. When I say corresponds, I mean located in the same spot. Okay, so this was on this left edge right here on the sticker. The left edge on the original sketch was right here, 7/8 inch. So those two lengths correspond to each other. Okay, let's take this 1 1/2 inch segment down here on the bottom left on the sticker, 1 1/2 inches. That corresponds to down here, the bottom left on the original of 75/100ths of an inch. Okay, next, we're going to take this 2-inch segment, which we've got labeled right here on the sticker. This 2-inch segment corresponds to this 1-inch segment on the original sketch. And then finally, we have this 2-inch segment, which corresponds to this 1-inch segment. When we set up these tables, we have to make sure that we set up the corresponding values correctly. All right. We want to know if the sticker is proportional to the original sketch. Now, the size of the sticker depends upon the original sketch. So the sticker is your dependent variable y. That means your original sketch must be x. And we're always setting up our ratios as y over x. So if we take a look at this first example, all right, we have 1 3/4 over 7/8. And remember, this is a complex fraction, and it just represents a division problem. What we need to do is to get a unit rate out of this. So to go from 7/8 to 1, 7/8 divided by 7/8 equals 1. So we need to do 1 3/4 divided by 7/8. Well, if you punch 1 3/4 divided by 7/8 into your calculator, you're going to get a value of 2. So this corresponds to a unit rate of 2 over 1. Next, we have 1 1/2 inches on the sticker, corresponds to 75/100ths of an inch on the original sketch. Get a unit rate out of this. 75/100ths divided by 75/100ths is 1. 1 1/2 divided by 75/100ths equals 2. So we get 2 over 1. Next, we have a sticker length of 2 inches, corresponds to 1 inch on the original sketch. This is already a unit rate because the denominator is a 1. So now I can move on to the last example, and notice I also have 2 over 1, which was already a unit rate. So if you look at the 4 unit rates, they all were equal to 2 over 1. So the question in A asks, is Jake's sticker an example of a scale drawing? Well, remember what we set up here. All scale drawings are proportional to the original drawing. Since this is a proportional relationship, then the sticker is a scale drawing. The sticker is a scale drawing because the corresponding lengths, again, that means located in the same spot, the corresponding lengths are proportional. We simplified all of the rates down to a unit rate, and we saw that there was a constant unit rate. So this means that we have a proportional relationship. Since it's proportional, that means that the sticker is a scale drawing, and B is asking, what type of scale drawing is the sticker? Well, if we go back up to the top, remember that there were 2 kinds of scale drawings. It could either be a reduction, meaning it got smaller, or an enlargement, meaning that it got bigger. If we compare the lengths of the original sketch, 1 inch corresponds to 2 inches. A 7/500ths of an inch corresponds to 1.5 inches. 7/8 of an inch corresponds to 1 3/4 inches. The sticker lengths are bigger than the original lengths, so this must be an enlargement. The sticker is an enlargement because it is bigger than the original sketch. Okay, if your scale drawing is bigger than the original, we call that an enlargement. If it was smaller than the original, we would call it a reduction. So in the box, we're going to list the steps to check for a proportional relationship, all right? Check for proportionality for a scale drawing and the original object or picture. The first thing that we need to do is measure the lengths on the scale drawing. Okay, get the lengths of the measurements on the scale drawing. And then after that, we're going to measure the corresponding lengths on the original object. Remember that corresponding means in the same location. Okay, then what we're going to do is set up ratios and look for a constant unit rate. Okay, and this is how we determined in the last example that the sticker was indeed a scale drawing. So in the box, this is one big key idea that we need to learn today. The scale factor can be calculated by finding the ratio of any length on the scale drawing to its corresponding length in the actual picture. The scale factor corresponds to the unit rate and the constant of proportionality. And for the scale factor, we use the variable k, just like we do for the constant of proportionality. In a scale drawing, when you find the constant of proportionality k, you're finding the scale factor of that scale drawing. And so here in question C, it says, what was the scale factor for the sticker? Well, if we go back and look at the table once again, when we set up all of our ratios, everything's simplified down to 2 over 1. So in this example for the sticker, k equals 2. That is the scale factor for the sticker. What does this mean about the relationship between the sticker and the original sketch? Well, since k equals 2, this means that the sticker is twice the size of the original sketch. Okay, so if you take a value from the original sketch and you multiply it by 2, you would get the value of the length on the sticker. K equals 2 means that the sticker is twice the size of the original sketch. D asks, what would a scale factor of 3 indicate? Well, if K equals 3, this means the scale drawing is 3 times the size. 3 times the size of the original object. Okay, so if K equals 2, it was twice the size. K equals 3, 3 times the size of the original object. In the next example, we're told that Jake created a computer icon for his game from the original sketch. It says to determine the scale factor for the computer icon. Okay, so let's take a look at these measurements. This is the computer icon, and we're going to list those measurements in the top row. So we'll start with the left side, which was 7/16, and then the bottom left, which was 3/8, and then the top right here, which we can call 1/2, and then this back side right here, which was also 1/2. We need to get the corresponding lengths on the original sketch. So 7/16 is this left edge. That corresponds to what on the original sketch? Well, the original sketch, the left edge right here was 7/8. So that's the value that we're going to put in this box right here. Okay, 3/8 of an inch. All right, 3/8 corresponded to 75/100ths of an inch on the original. A 1/2 inch corresponded to 1 inch, and again, a 1/2 inch corresponded to 1 inch on the original sketch. All right, the icon is dependent upon the original sketch, so we're going to set up our ratios again as y over x. Our first example says 7/16 to 7/8. This complex fraction is a division problem. 7/16 divided by 7/8. If you divide 7/8 by 7/8, you get 1. 7/16 divided by 7/8, you would get 5/10 or 1/2. So 1/2 over 1. Next, we have 3/8 over 75/100ths. 75/100ths divided by 75/100ths is 1. 3/8 divided by 75/100ths, you would get 5/10, which again is the same thing as 1/2, so it's 1/2 over 1. Next, we have 1/2 over 1, which is already a unit rate because the denominator is 1. And once again, 1/2 over 1, that's already a unit rate. So if we look at the 4 unit rates, we get 1/2 over 1 in each case. So when it says determine the scale factor, we're again looking for K. K in this example equals 1/2, or as a decimal, 5/10. This is the scale factor of the computer icon. So we just found the scale factor of the computer icon. It was 1/2 or 5/10. And question A asks, is the computer icon an enlargement or a reduction of the original sketch? Well, if you go and compare the size of the lengths on the computer icon to the original sketch, the computer icon is smaller, so we're going to call that a reduction, okay? It is a reduction because the icon is smaller than the original sketch. Okay, when the scale drawing is smaller, we call it a reduction. Letter B says, what does the scale factor indicate about the relationship between the computer icon and the original sketch? Well, remember, we had K equals 1/2. or the same thing as 5/10. That was our scale factor here. This means that the icon is half the size. The icon is half the size of the original sketch. Okay, so we had a scale factor of 2 for the sticker. That meant the sticker was twice the size. We have a scale factor of 1/2 for the icon. That means the icon is half the size of the original sketch. What if the scale factor is 1? What would that indicate about the relationship between the scale drawing and the original drawing? Okay, well, if k equals 1, well, if you take any number from the scale drawing and from the original drawing and multiply it by 1, you're going to get the same exact measurement. So a scale factor of 1 indicates that the scale drawing and original object are the same size. Okay, because if you multiply any value by 1, you get the same number back. So if k equals 1, this indicates that the scale drawing and the original object are the same size. So we're starting to get an idea about the scale factor. Question D says, if we only know the scale factor, how can we tell if the scale drawing is a reduction or an enlargement? Well, we just said right here in letter C that if k equals 1, they are the same size, okay? K equals 1 means that they are the same size. Well, we had an example up above in letter B where k was equal to 1/2. 1/2 is smaller than 1, and that represented a reduction. Okay, so if you know your scale factor k and it's less than 1, okay, this means a reduction. Okay, well, we also had a scale factor of 2 with the sticker. The sticker was an enlargement because the sticker was bigger than the original sketch. Okay, since 2 is bigger than 1, if your scale factor is bigger than 1, this would be an enlargement. Okay, so based off of the scale factor, you should easily be able to tell if you're working with a reduction or an enlargement. If your scale factor is smaller than 1, it's a reduction. If your scale factor is bigger than 1, it's an enlargement. And if your scale factor is exactly 1, the scale and the original are the same exact size. Okay, and remember, to find the scale factor, put a big star next to that. To find the scale factor k, you always put the scale length over the actual length because the scale length is y, which is dependent upon x, which is the actual length.